Okay, let's dive into this. Today we're unpacking the foundational infrastructure decision that dictates the capabilities of literally every single IP CCTV project. We spend so much time debating camera resolutions, fancy analytics, and software, but the truth is, none of that matters if the invisible physical foundation beneath it is flawed. We're talking about cabling for IP CCTV.
20. Just think about that number for a second. That single number represents the 2 decades that your invisible cabling infrastructure will either completely haunt your project or absolutely empower it. When you pull cable through walls, up into ceilings, and down into underground conduits, you are making a 20-year commitment. It's the invisible backbone. You install it once, and you rely on it every single day.
So, the crucial point is this. The wrong cable can support a system today, but completely choke it in 3 years when the inevitable camera upgrade arrives. The stakes here are massive, guys. If you underspec your infrastructure just to save a few pennies per meter today, you are literally guaranteeing a severe bottleneck when those new, high-bandwidth cameras drop in 36 months. We absolutely must specify this correctly the very first time.
Section 1. Choosing your copper. Let's get right to it.
Let's do a quick reality check on legacy tech. Cat6A, it gives you 100 MHz, 1 gigabit Ethernet, and up to Type 2 PoE at 30 watts. Sure, it's acceptable for short runs in tiny offices, but it is definitely not future-proof. Cat6 bumps you up a bit to 250 MHz and allows 10 gigabit Ethernet, but, and this is a big but, only up to a severely limited 55 meters. It maxes out at 60 watts of Type 3 PoE. Those are legacy standards. We need to leave them in the past. On the flip side, Cat6A is the new, non-negotiable minimum for any commercial CCTV project. It's an absolute powerhouse. It delivers 500 MHz, full 10 gigabit Ethernet up to a complete 100-meter channel, and supports Type 4 PoE at a massive 90 watts at the source, right in line with the IEEE 802.3b standard. Now you might be asking, what about Cat7 and Cat8? Just forget them for this application. Seriously. Cat7 uses entirely different connectors like GG45 or Terra, which makes it totally incompatible with standard RJ45 networks. And Cat8, it uses RJ45, yeah, but it's only designed for super short 30-meter runs in data centers. It's absolute overkill for CCTV. You really need to stick with Cat6A.
Section 2. Surviving the 90-meter rule. Let's talk about the laws of physics.
The TIA 568.2-D standard is basically the golden rule of structured cabling. It strictly defines a 100-meter horizontal channel, but notice how that breaks down. It is exactly 90 meters of solid, permanent cable running through the walls or trays, plus 10 meters of combined flexible patch cords at the ends. Pushing beyond that exact 90-meter permanent link, that isn't just slightly bending the rules, it's a total disaster. Your signal integrity degrades rapidly, and your PoE voltage drops right below the operational threshold. The camera simply will not power on, or if it does, it won't stay stable.
So here's a really common, high-stakes engineering problem. Think about this. What if your camera layout requires mounting a unit way out on a perimeter wall, way beyond that 90-meter limit from your switch? How on earth do you solve that without breaking those laws of physics? Well, you have 3 escape hatches to solve this. Option 1, move the IDF closer. You literally build a sub-IDF with a single switch and run an uplink fiber back to your main IDF. Option 2, use a PoE extender. These handy little devices sit right on the line, regenerate the signal at the 90-meter mark, and typically extend the run by another 90 meters per stage, depending on the vendor, of course. But remember, always look for managed extenders with monitoring capabilities, not the cheap, unmanaged ones. Finally, option 3, run fiber. You take a fiber optic line from the IDF out to a media converter near the camera, and then use a short Cat6A patch cord from the converter directly to the camera itself. In fact, for perimeters and PR cameras at parking entries and remote outbuildings, fiber is almost always the right answer.
Section 3. Backbone and fiber optics. Let's scale things up a bit.
Now, what's really interesting about this slide is how the fiber options map out. OM3 is your absolute bare minimum for new builds, giving you 10 gigabit speeds at 300 meters or 100 gigabits at 70 meters. OM4 pushes that even further to 400 meters at 10 gigabits, making it the standard recommendation for sprawling buildings like hotels and hospitals. And OM5? Well, that's for wideband shortwave wavelength division multiplexing. It's super useful in high-density data centers, but honestly, it's totally overkill for CCTV. Then we look at single-mode OS2 down at the bottom. OS2 is incredible. It will give you 10 gigabits and 100 gigabits up to a staggering 10 kilometers. It is absolutely mandatory for any inter-building runs over 400 meters and for establishing a truly future-proof backbone.
Section 4.
installation, and fire codes. Because a brilliant design can be ruined in seconds by a bad physical install. Let's drill right into the physical realities of an installation. First off, always terminate your Cat6A at a patch panel. Never, ever directly into a switch port. Patch panels protect your really expensive switch from physical damage during moves. And hey, if you're running shielded Cat6A, you absolutely must use shielded patch panels. Running unshielded cable to a shielded panel is just wasted shielding. Next, you have to respect the pull and the bend. Cat6A has a maximum pulling tension of just 25 pounds of force. Guys, it's a delicate data cable, not a tug-of-war rope. Yanking on a stuck cable destroys the inside. Use proper pulling lubricants and rod systems for those long runs. And the bend radius? It's 4 times the cable diameter, which is roughly 25 millimeters for Cat6A. Bending it any tighter literally crushes the internal twist geometry and completely wrecks your performance. Finally, label every single cable at both ends: floor, IDF, port, and camera ID. Having this labeling scheme mapped out speeds up troubleshooting by literally 10 times. I'm not exaggerating.
Physical safety means navigating fire ratings, because cabling isn't just about data, it's a massive network of combustible material running right through a building. Fire ratings keep buildings compliant and people safe, and this brilliantly illustrates the critical ratings you need to know, starting with CMR. This is your riser-rated cable. It is specifically built and rated for vertical runs, safely navigating between floors right inside a building's riser shafts.
Then we have CMP, which is plenum-rated cable. This is where your code compliance really kicks into high gear. CMP is mandated for runs in plenum spaces. Those are the air handling spaces you find above dropped ceilings or beneath raised floors. Commercial building codes almost universally require CMP in these specific environments to prevent toxic smoke from entering the building's air supply during a fire. It's incredibly important.
And finally, LSZH, which stands for Low Smoke Zero Halogen. This one is defined by strict IEC standards. LSZH is commonly mandated in high-occupancy buildings where evacuating people quickly is a real challenge. For example, it's heavily mandated by UAE Civil Defense and explicitly referenced in Saudi SBC 801. So, if you're designing for a project like a massive hotel in Riyadh, LSZH is absolutely non-negotiable. Always check your local fire codes.
Section 5. The Site Survey and Final Mandate. Let's talk about the real-world application. Whenever you walk a new project site, you really must run through this survival checklist. First, physically measure the exact distances from every single camera location to the nearest IDF. Do not guess. Just don't. Second, check your cable trace for pull string availability to see if the pathways are actually clear. Third, identify fire compartment crossings. Passing through these walls requires properly installed fire-rated barriers. Fourth, verify your patch panel space and switch port availability to see if the physical space even allows for retrofits. And finally, assess any existing structured cabling to figure out its exact category.
If you take absolutely nothing else away from this explainer today, burn these 3 unbreakable rules into your mind. Let's move to and see how this builds your final mandate. Rule 1. Cat6A is the new minimum, period. Do not accept Cat6 or Cat5E in any new design. Rule 2. 90 meters is the absolute maximum horizontal channel. Plan your IDFs accordingly or use one of our escape hatches. Rule 3. Use multimode OM4 for your internal backbone and single mode OS2 for interbuilding runs. Always.
I want to leave you with this final, provocative thought. Will your current cabling actually survive the next camera upgrade? Remember, this invisible infrastructure determines exactly what your system is capable of doing for the next 2 decades. You have to specify it like the future of your network depends on it. Because, honestly, it absolutely does. Thank you so much for joining me for this explainer. Next time, we're shifting gears from physical security to digital security, diving deep into IEC 62443 cybersecurity standards and how to harden your cameras against the next Mirai botnet. Make sure you're subscribed and keep building.